Hello and welcome everyone. In this video tutorial, we will discuss about Markov decision process. So without any further delay, let's straight jump to the topic. So basically, reinforcement learning, which we have discussed in the previous tutorial, is a subset of machine learning which enables agents and machines to automatically decide the best course of action within a certain situation, and it is done in order to maximize performance. Moreover, it also includes a reward feed which eventually helps the agent to learn how to respond. Now there are many machine learning applications that utilizes reinforcement learning to categorize a whole series of action. Typically, this reinforcement learning is a branch of machine learning that tackles this kind of issues by using the Markov decision process to simulate portions of its architecture. So let's discuss what is Markov decision process. Markov decision process is a mathematical function that is utilized to characterize an environment in reinforcement learning. This agent environment interaction in Markov decision process, which is also referred as MDP, is depicted in the diagram. You can see that diagram on the screen. So in this diagram you can see various components. Very first, it includes the word state, which is represented by ST. Then it also includes model. We will discuss about models further in this video. Then there is course of action, which is represented by KT. Then there is reward for a particular action, which is represented by R. And other than this, a Markov decision process involves possible solutions, which is also referred as policy. So before we understand the working of Markov decision process, let us understand each of its elements in detail. So these are the elements, where very first is the state. Now each possible state for the agent is represented by a set of tokens, which is referred as state. Then there is model. An action impact on the state is described by a model, which is often known as transition model, and it specifies a transition T where being in a state S and performing an action A moves up to the state S naught. After this, there is action, which is represented by A, and it is a collection of all the potential actions that are performed by an agent. The collection of all these actions that can be executed while in the state S is defined as AS. Then there is reward. So a reward R, which denotes the benefits of being in a state S and doing an action A. And in the last, we have policy. So decision Markov process has solution called a policy, which is a mapping from S to A, state to action. Moreover, it denotes an action A to be carried out when in a state S. So if I move in more detail, at each discrete time t, going from 0 to 1, then 1 to 3, the agent and the environment are in interaction. Then the agent obtains knowledge about the environment state, which is represented by ST, that we have seen in the previous diagram. Now the agent decides on an action AT in accordance with the state of the environment at instance t. An additional numerical reward, which is represented by R plus 1, is then sent to the agent at the same time. So next, let's understand this thing with the help of an example, and let us discuss an example where the goal is to keep the room temperature within the set of range. Now there will be multiple external variables like outside temperature, the heat produced internally, etc., and these factors will have an impact on the temperature inside the room. Now here the agent is the heating coil, which must determine how much heat is needed by interacting with the environment to manage the room temperature and make sure it stays within the certain range. In this instance, the reward is essentially the price paid for departing from the ideal temperature range. Now in this, the room simulator, which is essentially a heat transfer mode that determines the temperature based upon the dynamic load, is given. This dynamic load and the instance which simulates the model is the environment. Now both the present and the future reward are contained in the state variable. So with this, I hope you got a clear overview related to Markov decision process, and with this we have come to the end of this tutorial session. Thank you for watching. We will see you in the next one.